OSIRIS-REx is NASA's first asteroid sample return mission. So OSIRIS-REx will spend about 2 years journeying to asteroid Bennu. Once we get there, we'll spend a couple years surveying the surface of the asteroid to find the best place to get a sample from. And then we'll go ahead and return it to Earth and have that sample for scientists to study in perpetuity.
OSIRIS-REx is an amazing mission. It's the third mission in the New Frontiers line, a PI-led mission to go to asteroid Bennu, collect a sample, and bring it back to the Earth. Asteroid Bennu contains isotopes, minerals, and chemicals from the early solar system. And by studying these on Earth, we'll better understand the origin of the solar system, the origin of planets, perhaps even the origin of life.
Bennu was chosen as the target asteroid from the science team after evaluating 3 critical criteria, the first of which was accessibility. So Bennu is really optimal. It has an orbit of about 1.2 years and it passes by Earth every 6 years. Second criteria was the size. We needed something large enough to where it wasn't rotating too fast. The smaller the body, typically the faster it rotates. We wanted something that we would be able to do close proximity operations with, all that detailed mapping we want to do of the surface. And we wanted something that was rotating at a speed that we could be able to match and then slowly lower ourselves to retrieve that sample. The third criteria was the composition. We wanted an asteroid that was pristine, that had a known geologic context, and that was carbon rich. And Bennu really fit the mold for all 3 of those criteria, and that's why it's the destination asteroid.
OSIRIS-REx arrives at Bennu in August of 2018. And our mission profile is designed to get us ever closer to the surface of the asteroid to understand the nature of its surface. What we really want to know is, can we get the spacecraft down to the point where we want to get the sample? We call that deliverability. If we reach that point, will the spacecraft remain safe? Meaning it can get away from the asteroid and still be functional, especially for returning a sample to the Earth. And then we also want to know, if we touch down on that spot, will we get a sample? We call that the sampleability assessment. So those are the key parameters that drive our observation planning of Bennu. And we're going to spend about 10 months globally mapping the asteroid and then performing detailed site reconnaissance of specific locations where we think we want to get the sample.
25.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
What I personally am most excited about for the OSIRIS-REx mission will be the first images that we get when approaching Bennu. So right now we have a sense of what Bennu looks like and what its shape is from ground-based assets like Arecibo and the Goldstone radars, but we won't know what the shape is completely. We won't have a perfect sense of it until we actually encounter the asteroid. I am going to be really excited when those images come back.
For me, getting that sample back to Earth is the most exciting part because we will have something that preserves material from over 4.5 billion years ago. Who doesn't want that? So sample return is really the most exciting part, I think, of this mission.
I've been working on OSIRIS and its precursor concepts since 2004. The launch is about the halfway point. So for me, launch is a major milestone, but not the most exciting part of the mission. The most exciting part is the stories that Bennu has to tell us that we haven't even thought of yet.
And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.